Hi everybody, today we're continuing on with metals. We're looking at 3.2. What we're really focusing on today is to look at the reactivity of metals and how that is related to their atomic structure. We've done a bit of this already in the previous two chapters. We're going to look at using the reactivity series to identify in which metals, when we combine metals together, in which ones a displacement reaction occurs. You did displacement reactions last year, but you might have forgotten. So your success criteria today is to be able to explain how the reactivity of metal is related to its location in the periodic table, and then to answer questions 3.3 correctly and confidently. We've skipped on a slide. Okay, this one here you may have seen in the past. This is where Brainiac puts different metals in the bathtub. And if we go down group 1, we know that lithium, a bit of a fizz, sodium, a bit more, rubidium, basically he blows up the bathtub. You can watch this one later on. So looking here, if we look down here, the least reactive metals are things like platinum, gold, silver, copper, things that we find as elements in the ground. Whereas things like potassium, sodium, calcium, magnesium, even aluminium, they're found as oxides in the ground, and we need to refine them in order to get the pure metal extracted from the oxygen. So if you think of the Portland aluminium smelter, their job is to turn aluminium oxide into aluminium ingots. Okay, there is a song about the reactivity of metals, but I'm not worrying about that one today. Okay, so in general, the reactivity for the main group metals, so remember the main groups, so groups 1, 2, 13, increase going down the group in the periodic table. If we look across, going from group 1 to group 2, it decreases across the period. So sodium is less reactive than magnesium, is more reactive than magnesium. Potassium is more reactive than calcium. This trend in reactivity is explained because of the relative attractions between the valence electrons, the outer shell electrons, and the nucleus. When metals react, they form positive ions or cations by donating or giving up their outer shell electrons. They're the ones involved in chemical reactions. The metal ions that require less energy to remove one electron tend to be the most reactive. And they're the ones with the lowest ionization energies, and they are at the bottom left-hand corner of the periodic table. And that's it. Please answer questions 1 to 4 on page 35. Short one today. Be even shorter if I could work where the stop button was.